so many aspects of our lives are integrally dependent upon our ability to harness the power of electricity.
The work that an electrical engineer does can be extremely varied.
From the tiniest little computer chip research for something that's 1,000th or 10,000th of a human hair, to someone working on a wind turbine in a field which is, enormous in scale.
Basically anything to do with magnetism, electricity, and all that.
Pretty much everything that we think of in our modern culture comes back to electrical engineering.
Once you get to a higher level, it pretty much branches out into anything.
You can study electrical engineering, but if you want to work in medicine, imagine an emergency room. You are surrounded by electronics.
I did some instrumental design for DNA sequencers.
You could go into electrical engineering with a little bit of computing focus, and you could work for an internet startup.
It is very interesting. And every time I enter the lab, I learn something new.
Well, we have electrical engineers that, because they can understand these really complex circuit systems, they'll help people model traffic jams in large cities and help them mitigate that. But system is a really broad term, so I'll give you an example. We have someone that works here where he's an electrical and he does system level work, but he basically puts sensors on bridges, and then they'll go to one end of the bridge and they'll basically hit it with a fancy hammer, and then they can model the whole bridge as a system and basically determine in its end of life, and if they can basically just fix this strut over here, it's going to last 5 more years and it's going to save you $20 million.
It's the balance between those two things of delivering something that is useful to the public, but at the same time getting to push the boundaries of science.
We've created some of the world's first transparent displays, like a truly transparent color display that looks like a window when it's turned off.
In our lab, we concentrate a lot on lab-on-a-chip devices, so instead of sending a sample out to a lab that would take 48 hours to analyze, we could basically make everything on one single chip, and then you could analyze that within a few minutes.
We've also, in that same display area, we've worked on electronic paper. So imagine an iPad that you can fold up and drop in your pocket as well.
When somebody has had a mild stroke, they may have had a little bleeding from the brain into the cranial cavity. And so we've developed a device that shines light through it. Then we use mathematics that are very similar to how a cell phone figures out whether it can communicate with a radio tower, to actually analyze that color spectrum and determine whether there's bleeding in there that is indicating that there's been a stroke.
Well, I decided to be an engineer when I was 14.
I went through 2 years of training in the Navy to do basically be an electrician on a submarine.
I always really was interested in science, always. Even in my spare time, that's what I did.
I was like, okay, yeah, one day I want to make a device which would be useful.
While I was on the boat, pretty much anything electrical that broke or was not working, we pretty much had to fix.
And I didn't even know what a PhD was when I started. I had never even heard of it. I don't come from that type of family at all.
Once I got out, I kind of wanted to pursue a little bit higher level, and then that's kind of when I did my undergrad here at UC.
I mean, electronics is just a base. Once you go become a doctorate, you have a doctorate, you can work in interdisciplinary fields.
What do you have in STEM? Science, technology, engineering, mathematics, right? All 4 things are required in electrical engineering. Being willing to take that algebra class or that calculus class or that physics class in high school, and even though everybody thinks it's hard
to envision the importance of these things early on, but as you get into your 2nd and 3rd year of study, all of a sudden you'll see all those fundamentals you study start to come out.
In almost any engineering program, you're going to get lots of math, lots of physics, lots of the basic sciences to build your foundation on. And then you're going to learn processes of design and how to document the work you do.
There are a lot of good technical colleges which can get students started right away, where you might not have to go as advanced in some of the math.
There are outstanding undergraduate institutions in Ohio.
And if you're motivated because you like what you do, then you're going to be more successful, and then you're going to be more motivated, and it just feeds upon itself, and the rest takes care of itself.
Having that desire and that passion for learning, that's the key thing. You could be a chip designer. You could work in a chip manufacturing facility. You could design the control and life support systems that enable the astronauts to live in the space station.
So I want to go, develop my own technology and license it.
You can go into the stream of medicine because, frankly, biomedical devices have been the rage.
It's really endless. And what's really amazing about being in a technology field is that everything I've listed today, there are 10 times as many of those things that we don't even know yet. That by the time a high school student gets to starting their professional career, there will be jobs doing things that we haven't even imagined yet.
I basically get to play with cool things all day. I mean, that's all I do, and I get paid for it.